everyone. Thanks for coming out this evening to our workshop with Intro to Databases with SQL. Okay, alrighty, I'm just admitting a few more people. Okay, alrighty, so we're gonna get started now. Before we get completely started with the workshop though, I'm sure you all know we've lost a valuable member of our UPE family, DeJuan Harris. He's made a really big impact on this organization and he's going to be greatly missed. So to honor him, we're just going to have 1 minute of silence. So please make sure you're muted and just keep him in your thoughts, his family in your thoughts during this moment of silence. So we'll start that right now. Okay, thank you all. I appreciate that. Okay, so let's see. Before we get started, I also want to remind you all, if you haven't joined the Discord server yet, please do so. This is the link to join it. So over there, we keep track of all the events that are coming up. There's lots of chat rooms from homework help to discussions and gaming, etc. So if you haven't joined our Discord server, please go ahead and do so now. There's the link. And yeah, so welcome to our Intro to Databases workshop with SQL. So I'm happy that you all can make it this evening, and I hope you gain something from this workshop this evening. Okay, so let's get started. So why learn SQL? So SQL has been around for a while. Honestly, I think it's been about like 50 years now that it's been around, but it stood the test of time and it's remained relevant for so long because it's so useful. So if you happen to be interested in just the realm of data in general, so possibly if you'd like a job in data analytics or data science, SQL is basically necessary to have in your toolkit and along with your other skill sets. If you browse like job listings, internship listings, etc., it's definitely in the required fields as skills employers would like prefer you to know. But I think the best part of SQL is that honestly, it's fairly easy to learn. So once you understand the schematics of a database, like the layout of a database, it becomes a lot easier to query the information and pull it out, etc. So SQL isn't a very difficult thing to learn. And so yeah, that's exactly what we're going to do today. So we'll start by going over some basic fundamentals when it comes to data. So relational databases, database management systems, and then we're gonna apply some of what we learned with a quick demo. And this is just a reminder, if you haven't downloaded the software that was linked on, like, I think that was the Notion page, and you'd like to follow along with the demo, this is a good time to download it because we have a few minutes before we get to that portion. And I'm gonna go ahead and send the link in the chat. So I apologize, there was some confusion when it comes to which like version you have to download. So for the MySQL community server, that's what you should be downloading. And then if you are a Mac user, go ahead and download the DMG archive. And if you're a Windows user, go ahead and download, I think it's the MSI file. It's like, you don't even have to scroll down. It's like the first like link there if you're a Windows user. So yeah, so go ahead and download that. Also, if it prompts you to create an account, don't worry, you don't have to create an account. There's like a link somewhere at the bottom that says like proceed with my download or something like that. Go ahead and click that, and that'll get you downloaded without creating an account because it's not necessary. But what you do need an account for is PopSql. So we'll be using that today as well. So if you haven't created an account, you have to do, oh, there are two MSI. Yeah, there's two. So go ahead with the one that you think is going to be most compatible. I think there's one that's like, let me go look, because there's one that's like for, yeah, there's one that's 2.4 megabytes and there's one that's 422.4 megabytes. So just download whatever your machine can handle. I suggest the 2.4. I don't think you need much more than that. So PopSql, no, I think it's pronounced PopSql, Pop SQL, whatever. It's kind of interchangeable. But okay, so in the meantime, we're gonna start our actual presentation, go into some background information about data, etc. So I wanted to start with data versus information. So because I think it's important to start by clarifying what exactly we're working with in databases. And to be clear, there's a difference between data and information. So I, to this day, get them mixed up and I use the words interchangeably, but there is a difference. So data is raw facts and information is processed raw data. So when there's context added to raw data, you end up getting information. So let's say somebody gives you just like a reading of 105 degrees. So that's kind of arbitrary. It doesn't give us much information. We need more context. So is this degrees in Fahrenheit? Is it in Celsius? Is this somebody's body temperature? Is this the temperature outside? Like these are all things that it's important to have context for in order to make it information and not just data. So that's where we start with data and information. And then there's this further level, I'm laughing at the chat with the popsicle. And then there's, oh, and Suleiman, you're asking which one should you download? It depends on your operating system. So yeah, if it's Windows, then go ahead and download the MSI and go ahead and just get the one that's like the smallest like data that it takes up. But yeah, if you have further questions, let me know. Okay, all right, thank you, Alejandro, for linking that. Okay, and so that's the difference between data and information. And then we have this further level that's called knowledge. So when we move into knowledge, these are facts about a specific subject. So it implies that there's an awareness and an understanding of information. So it kind of goes in this form. So we have data at the foundation, and that's the foundation of information. And then on top of that information, we have knowledge. So then when we combine those three things, we're able to recognize patterns, we're able to make good decisions, and that's really important when it comes to data analysis. So that's just a little bit about that, just to clarify what data even means. And then further, there's such thing as metadata, which is data about data. So it's also known as a data dictionary. So once again, this is giving further context to kind of like arbitrary numbers. So like basically if you have a table, you can get, oh, I'm sorry, you can give a name to that table or like a type of value. Is it numeric? Is it a date? Is it text? How is this data stored? That's basically how we sum up metadata. So that's the definition of that. All right, so let's get into what a database even is. So yeah, so we're talking about all the organization of data. What's the definition of a database? So a database is any collection of related information that can be stored in different ways. So a database can be stored on paper, It can be stored mentally in your brain, and it can be stored on a computer. Obviously, that's what we associate a database with usually. But for example, a phone book, a shopping list, a to-do list, those are all examples of a database because it's related information that's stored together. However, Facebook's user base, that's a database as well, because once again, this is all that related information stored together. So that's the layman's kind of definition of what a database is. So next, we know that computers and databases obviously go hand in hand. Like I said, that's what we associate usually with databases, a computer. And they go hand in hand because now we're combining data, hardware, software, and users like in one fell swoop. So everyone gets involved when we use a computer and a database. And this is obviously the most efficient way to store and keep track of large amounts of data and information. And typically computers and databases, they contain end user data or raw data and metadata. So, and then not to mention, there's this added layer of security as well when you use a database on a computer. It's more accessible, it's more organized, and like I said, it's added security. So let's compare that shopping list to the billions of records that Amazon.com has. It's like night and day. So there are actually various types of databases. There's two slides of types of databases, and there's more than the ones that I even listed here, but I'll go ahead and go through them. So there's a single user database. So it's exactly what it sounds like. It supports one user at a time. So this example, I don't know if this counts anymore because I think they changed it, but like think of like Spotify or Tidal. Those were considered single user databases because when you listen to your music, you're the only one who can be listening to it at that time. But I only hesitate because I really think they just changed it. And I think like more than one person can listen at a time now. But yeah, so that would, when it was just one person being able to listen to Spotify, that would be an example of a single user database. Then we've got multi-user databases, so that supports multiple users simultaneously. We have distributed databases, so that's when the database is stored in 2 or more physical locations, like independent sites. And then the opposite of that would be a centralized database. So those are databases that are located at one site. And then, of course, we have cloud databases, which is self-explanatory. It's exactly what you think it is. It's a database that's created and maintained using cloud services. So think about Microsoft Azure and Amazon AWS. Those are cloud databases. So even further, there's a desktop database. That's a type of single user database, and it runs on a personal computer. So your personal computer is technically a desktop database. Then we've got a workgroup database. So that's a multi-user one. So multiple people can use this database, but it supports fewer than 50 people. So think about small departments within companies or organizations. If it's less than 50 people, that's a workgroup database because it's only supporting, a small amount of people. And then the opposite of that would then be an enterprise database. So it's for large companies. It supports way more than 50 users. And then towards the end, we have a general purpose database. So this contains a wide variety of data used in multiple disciplines. So you can think of when someone takes the census, there is a lot of information kind of condensed into a census. So that is technically a general purpose database. And then we've got a discipline specific database. So it's the opposite. It's now focused on a specific subject. So if you've ever used like a research database or like some sort of academic database to like maybe do research for like an English paper or something like that, that would be a discipline specific database. Okay, so let's get into database management systems. The acronym is also DBMS. So really it's a collection of programs that manages the database structure, and it controls access to the data stored in the database. So essentially it's there to help users create and maintain a database. So it's a software program. It's not the actual database. It's the management system that helps people maintain that. So I know I'm using the word data a lot, so sometimes it gets like a little confusing, like, you know, what exactly we're talking about, but I'll have a diagram later to hopefully like clarify it a little more. So yeah, so we'll get into more of what does a database management system do. So it does exactly what it sounds like. It manages data. So, and it makes it really easy to handle large amounts of information. Like we said earlier, there's this added layer of security as well. With DBMSs, you're able to back up your data. You're able to import and export your data. And if need be, it can interact with other software applications if you need those additional things to manage your data. Okay, so as I said, this diagram hopefully clarifies how all of these systems interact. For instance, let's say we have a workgroup database at a small company. So those are our end users over here to the far left. So those are the employees at our company. And then to the far right, we have the database. So that's where their data is stored. So think of a company. It can store anything from invoices to the clients they may have, to work schedules they have, just to like the employees' date of births, like that's all within the database. But right in the middle, we have our database management system. So our users make requests to the database management system, and then that database management system goes to the database and attracts whatever data that the information that they're looking for. It organizes it into a format that, you know, is perfect for them, and now the user gets it as an output. So that's how all of these systems interact. So that's the difference between a database and a database management system. Okay, so you're going to hear this term as well, a relational database. So what is a relational database? So it's a database that allows you to group items into one or more tables, and those tables are related to one another by using like common fields in each table. So yeah, so essentially it organizes data into tables, and think of it's literally a table. So tables that are formatted into columns and rows, and there's unique identifiers in each row. So later in the presentation, we'll get into what those unique identifiers are and etc. So popular relational database systems that you'll see today, we're working with MySQL, that's a popular one, MariaDB, and then of course Oracle, that's actually the most widely used relational database management software. And quickly, we're going to touch on NoSQL. So you might have seen this term as well. Essentially, this is the opposite of a relational database system. It's a non-relational database system that's used for storing and retrieving data. So basically, it organizes its information without using a table. They store it in a different way because sometimes a table isn't the most effective way to store this information. So if you think of things like just with recent innovation, so like IoT devices and like location data, that requires a lot of processing. And for that amount of information, just a simple table isn't going to work out very well. So NoSQL is designed to scale in a way that accommodates those big sets of data. So popular non-relational database systems that you may know of is MongoDB. So when I was saying that things aren't stored in tables, this is how they're stored. So it's technically document oriented. So that means it stores its information in like JSON files. We've got Redis, which is a remote dictionary server, and they store their information with key values. And then there's Cassandra. So Cassandra was actually developed at Facebook to aid in their inbox searches. Okay, so here's another term that you will also hear, it's CRUD. This essentially sums up the four main operations of a database management system. So its operations are to create, to read, to update, and to delete. So those are all of the things that summed up that a database management system does. Okay, so what is SQL in general? So SQL, SQL, it's interchangeable, you can go by either, but it stands for Structured Query Language, and it's a standardized language for interacting with that database management system. And it's also used to perform CRUD operations and other administrative tasks. and we use it to define tables and structures. So to be clear, SQL is not technically a programming language. It's a non-procedural language. So that means you merely command what you'd like to be done, and it gets those things done. So although it's not a programming language, it does fall under these categories. It encompasses the following things. So it's a data query language, which means it can retrieve stored info from using queries. It's a data definition language, or a DDL, because it's used for defining database schemas or layouts, so database layouts. It's a data definition language because it's used for defining database schemas or other, oh, I just repeated myself, sorry. It's a data control language, or a DCL, because you can use it to control access to your database, so you can grant users access and permission, for instance. And it's a data manipulation language, which is a DML. And you can use it to manipulate data, so insert, update, and delete things. So at this point, you've heard me use query like a couple times, so let's discuss what that is as well. So queries are requests that are made to the database management system for specific information. So essentially, it's like a set of instructions that are given to the database management system, and queries are written in SQL. So the more complex your schema, your database schema, or AKA your database layout, it gets increasingly difficult to retrieve the information we want to work with. So think of databases with like millions and billions of records. You need an efficient way to retrieve it. So queries help to get that output. So queries kind of ask questions like, what products are currently held in inventory that are priced over $100, and like how many are in quantity or on hand of these products, or how many employees have been hired since February 10th of 2020 in this company's department. So things like that is the information that we want access to when using queries. So literally an everyday example of a query is a Google search. So we use that all the time. We type something into the search bar, and then Google presents that organized info to us. So you can even use operators to narrow down your search. And it's the same with queries. You can use specific commands and operators to make that search even more narrow too. So yeah, I'm gonna briefly touch on ERDs. So it's an entity relationship diagram. So basically, this maps the relationships between tables, and it's the constructs used in the ER model can easily be transformed into relational tables. So in layman's terms, I think it's like a blueprint. So whoever's designing this database, the database developer, basically they can create this table, show how these different tables interact with each other, their relationships. And then once we see how they react, interact with each other on paper, it's a lot easier to transfer that into software. So if you've taken a programming class, I think this is really similar to a UML diagram, which is the Unified Modeling Language. So when you make that diagram, when you put in your methods and like inheritance and all those things, you just want to see how the system interacts. That's the same exact thing that we do with an entity relationship diagram. We see how the different tables within our database react because that's their relationships, because it's important because sometimes there's one-to-many relationships, many-to-one relationships. And so this is like an example. I know it's like kind of small, but it was kind of just there just to like put there, but you can see how they're all interacting in different ways and how they all relate to each other basically. Okay, so now we're gonna get into tables and keys. So like I said, I've been using these words a lot, so now I just wanna like drive home like what these mean. So a table and a key and attributes and things like that. So a table is exactly what you would think it is. It's a two-dimensional structure composed of columns and rows. So like we talked about earlier, relational databases store their information in tables, while non-relational databases store it by other means. So today, we're only focusing on relational databases. Excuse me. Okay, so the vertical columns of a table, those represent single attributes, and then the horizontal rows represent individual entries. So here's an example of that to wrap your head around, basically. So this is a table representing some random FIU students at FIU. They're not real Panther IDs or anything like that, but we see our Panther ID, the name, and the major. Those are columns and they count as single attributes. Whereas the horizontal rows, like for instance, Rory right here, this is a single entry because he represents one student. So that makes sense. The columns are attributes and the rows, the horizontal rows, are individual entries. Okay, so keys. So when you look at this table, there's more information there that, what immediately meets the eye, and so that's when keys come in. So a key is one or more attributes that determine other attributes. So I guess a good way of describing it is almost like metadata. So it's there to describe the data even further. So yeah, they're used to establish relationships among the tables and ensure the integrity of the data. So ensure that there's no like redundancies and things like that. So first and foremost, any table that you make must have a primary key because it uniquely defines each row. So if there's not a uniquely defined row, then that means that, the data in there isn't really accurate. We shouldn't have duplicates and things like that. Everything needs to have something that uniquely identifies it, which would be a primary key. A surrogate key, that means there's no mapping to the real world. So for instance, on that last table with the Panther ID, that would fall under a surrogate key because honestly, our Panther ID, it's good when we use it on campus and at school, but aside from that, outside that environment, it doesn't really have any significance. Whereas a natural key maps back to the real world. So let's say we had a table and it had your social security number on it, then that would be a surrogate key because your social security number holds quite a lot of weight in the real world. And then a foreign key is an attribute on a table that links to another table. So it's basically the primary key in another table. So yeah, I know these definitions kind of like all sound the same after a little while, and sometimes it takes me a little bit to like remember which one is which, but I have like some examples to hopefully, help bring that home. So let's talk about the primary key. So like I said, each table has to have a primary key. And a primary key is, once again, an attribute that uniquely identifies a row. So here, with our Panther IDs, no one student at FIU shares a Panther ID. Everyone has a unique one. So that's what's going to make it a primary key because they're all unique. And so then let's say we have this example for our foreign key. So we have the table that we just saw last. And say we added another table that now records the student's GPA and their credit hours. So what's still in common is these Panther IDs. So this is the primary key here. And so since it kind of basically inherited this primary key, it makes it a foreign key now. So yeah, so the red highlighted column, that's the primary key. And the blue highlighted column, that's the foreign key. So that's what's defining the relationships between these two tables. Even though they have different information, they're linked together by sharing those same Panther IDs. So some more information on keys. Like I said, there's actually a lot of keys and I didn't list them all today. I just wanted to show some common ones, I guess. So we have a composite key. So that key needs two attributes in order to define something. And so usually that's used when values are repeated. There's a super key. So that's any set of columns that can be combined together and they're unique. So typically there's multiple super keys in a table. And then there's a secondary key. So a secondary key is essentially the key that could have been selected to be a primary key, but it wasn't. So here's an example of a composite key. So this is a completely different table from what we were looking at. These represent maybe some like high schoolers and their attendance. So as we can see, the date and the name and the class period all together make up the composite key, because let's say we have a student here and their name repeats. So like maybe there's 2 Ashleys in the school. So we can't just go by this attribute alone because all of those values are the same. We can't just go by present alone because it's just a yes or no. We can't go by class period alone because that doesn't give us much information. And like I said, we can't just go by name alone because we have a name that repeats. So when we combine all of these attributes together though, that's when we can get unique information basically. So this Ashley and this Ashley, the difference between the two is that one was present and one was not present, but we were only able to get to that information because we had to combine attributes. So that's what a composite key is, literally a composite of different attributes. And then back to what I said about a secondary key. This is once again like a FIU example. So we know, once again, nobody can share a Panther ID. They're all unique, but what also is unique is everyone's FIU email. So nobody's FIU email repeats, it's all unique to somebody. So it could have been chosen to be a primary key. However, Panther ID was chosen to be the primary key. So that's just what a secondary key is. It's something that could have been chosen to be primary, but instead it's just secondary. Okay, great. So let's get into SQL commands. So essentially, we just want to understand what the syntax we need it to use to manipulate and change and like classify data. And to just to mention SQL commands, I think there's only like 100 words in the SQL vocabulary. So as I was saying earlier, it's not necessarily difficult to get a hold of because most of the commands are pretty self-explanatory, and you'll see that as we go on. So for starters, data types. So with our columns, we need to define the data type because we need to figure out what kind of information it can hold. So can it hold integers, characters, money, date and time, binary, etc. So basically we can break down the fundamental data types into 3 sections. So character, so that's exactly what you would think. It's alphabetic. Sometimes you can use digits. You can use special characters. So in like coding and programming, that's basically most similar to a string. So you'll see the type varchar to represent a character. And then we have numeric data types. So these are composed of digits. So that can be int, decimal, etc. And then we also have dates in SQL. So it's exactly what that sounds like as well. You can use a date data type or a timestamp data type. Okay, so let's look at what actual commands kind of are within SQL. So like we touched earlier, it's not a programming language, but it encompasses a couple languages. So these are the Dml commands, which means data manipulation language. And so these are the commands we use to manipulate data. So the majority of these commands are used to insert, update, and delete data. So we're not going to use like all of these in our demo today. We're just going to practice a few of them, but I'll just like list them off. So we have select, so it does exactly what it sounds like. It selects attributes from rows in 1 or more tables. We have from, that specifies tables from which data should be retrieved. We have where, that restricts the selection of rows based on conditional expressions. We have group by, and that groups the selected rows based on 1 or more attributes. We have having, and that restricts the selection of grouped rows based on a condition. We have order by, that orders the selected rows based on 1 or more attributes. Insert, we can insert rows into a table with that one. We have update, and that can modify an attribute's value in 1 or more tables or rows. And then we have delete, so deletes 1 or more rows from a table. And we have a few more Dml commands. So just like in programming, you can use operators as well. So equal to, less than, greater than, less than or equal to, or greater than or equal to. And then the 2 symbols when they face each other, that means not equal to. We have and, or, and not operators as well. So For conditional expressions, we have between, so that checks if an attribute value falls within a range. We have in, and that checks whether an attribute value matches any value within a list. We have like, and that checks to see if an attribute value matches a given string pattern. We have is null, and so that checks to see whether an attribute is null or not. We have count, which returns the number of rows with non-null values of a given column. We have minimum and maximum, which is self-explanatory. It returns the minimum or the maximum attribute value in a given column. And same with sum and average. That returns the sum or the average attribute found in a given column. Okay, so now we get to Ddl commands. So that stands for data definition. So these are the commands that we use to define our database layouts. So how do we create a table? We use the command create table, and it creates a new table in the user's database schema. We have not null, so that ensures that a column will not have null values. We have alter table, and that modifies a table's definition. So you can add, modify, or delete attributes or constraints. And then we have drop table. So that permanently deletes a table and all of its data. And then lastly, we have DCL. So I think that was data control command, data control language. So like we said, this can be used to control access, like granting users permission, for instance. So there's the commit command, and that permanently saves data, data changes. We have the rollback command, which restores data to its original value. Excuse me. We have grant, which gives a user permission to take a system action or access a data object. And then we have revoke. So it does the opposite. It revokes the previous access that a user might have had. So that is, in short, some of the commands that you can use with SQL. And like I said, we're not going to be using all of them today, but I wanted to list them all because this is being recorded. So if you ever want to go back and have access to just a laundry list of all of them, here they are. Okay, and so then we're going to touch on joins. So let's think back to when we had those double tables. This is how we combine information and pull data from both tables. So we have an inner join, so that returns records that have matching values in both tables. Hence, you know, the shading between the two, that's where they match. We have left join, so that returns all records from the left table and any of the matched records from the right table. But if it doesn't match, then it doesn't return anything else from the right table. We also have a right join, which does exactly the opposite. It returns everything from the right table and the matched records, but from the left table, if it doesn't match, it doesn't return it, only returns the matched records. And then we've got a full outer join. So that returns all of the records when there's a match in either left or right of the table. Okay, so I know that was kind of like a lot of just words and information and things like that. But like I was saying, once you understand how to set up a database and just how data interacts with each other, the rest of it becomes pretty easy. So that's essentially all of the background information that we wanted to go over. So now we're going to move into our demo portion. So actually give me 1 second while I move my screens around so I can show you all exactly what I'm doing. Also, for those who showed up a little later, oh, I'm sorry, I haven't been looking at the chat. Yeah, exactly, it's their associations that matter. Anyways, so if you showed up a little late, I was kind of explaining that I'm so sorry that I didn't specify between the different systems that you have to download based on your operating system. So if you're using a Mac OS, let me link the, oops, I lost it. Okay, let me link the SQL server again. So we're gonna use my community server. Oops. This is the installer that you use if you have Windows, and if you have a Mac, just go to the drop down and choose Mac OS and download the DMG archive. And then secondly, we're going to be using PopSQL as well. So with that, you do have to make an account. You have to just, put your email in. You can use your FIU email, spam email, it doesn't matter. And once you enter that in, you're gonna have to get a verification email in order to actually download the software. So like I said, I'm gonna pause really quick so I can move my screens around. But in the meantime, if you haven't been able to do so and you wanna follow along with the demo, this would be a good time to go ahead and download it. So give me 2 seconds. Okay, is everyone kind of caught up and still with me right now? Still downloading things? Oh, I also want to mention when you're downloading MySQL, the community server, just go ahead and go by its default settings. But at the end, it's going to ask you to set a password. Just make sure it's a password that you remember because we're actually just going to use it in just a minute. But for those of you who are already set up, this is also one thing that I didn't clarify, so I'm so sorry. I totally forgot that Windows users exist. I'm just always on my Mac, so sorry. If you're a Windows user and you downloaded MySQL, the following instructions that I'm going to go through is how to connect your server if you're using a Mac. If you're using Windows, fortunately, I think the process is actually simpler. I think if you go to your start page and you type in the search bar, I think MySQL command line, I think it's command line or command prompt, that should pop up, and then you should be caught up with us. So just give me a second, and if you're a Mac user, you can follow along with me and we'll get our server connected. So for starters, go ahead and open your system preferences just to double check. So you can come down here to MySQL and actually go to the application. If it does not say start, if it doesn't say stop, if it says stop MySQL server, then you're all good. It started automatically. But if it didn't, go ahead and start it up. And then you can go ahead and open your terminal. So this is what we're gonna use to get started. Okay. So if you go, you all can see my terminal, correct? Okay, good. Thank you. All right. Okay, so we'll type in MySQL. And we should get that. We should get access denied or command not found, etc. That's just fine. We're gonna go ahead and connect to it because basically we have to tell our computer, hi, we have SQL installed. This is where you have to go to get it. Okay, so we're gonna type in this specific command. So it's echo export path equals user local /MySQL /bin $$ $path, and then the single quote, $, greater than symbol, and then the little tilde, and then a \bash underscore profile. So you don't want to type all of that in. I'm going to go ahead and copy it in the chat so you can run that. So let's see. After we run that, we have to run one more command. So this makes it so we can run like the SQL Server like within our terminal. Okay, so the next thing that we do is dot, little tilde again, backslash dot dash underscore profile. Okay, I'll go ahead and copy that as well if you'd like to use it. You're welcome. Okay, awesome. So now we should be in a position to actually connect and log in. So the way that we do that is we type in MySQL -u, so that stands for username, and the username is root, and -p, which stands for password. So when we enter that, this is why I told you to memorize that password, because whatever you use to set up your SQL, this is where you would use it, okay? So 1, 2, not me saying my password out loud. Okay, alrighty, so we're connected. That's great, we're all logged in. Yeah, so this is where we go to actually start and create our database. As we said, oh, anyone have, for your PC, if you're using Windows, I think this is where you can get started. So can anyone confirm that when you downloaded the MSI and you went to your like start to like search for it? Yeah, that's what I was gonna say. When you pull up the command line and you type in MySQL, I think it should connect automatically. Yeah, I'm so sorry. I'll try my best to help, but yeah, I'm not really sure exactly the setup for that. Okay, so while we're here, now we can actually start and create our database, which is super cool. So we type in create database, and you can name it whatever you'd like. I'm just gonna name it SQL Workshop, just so it's easy to remember, it's general, and there we go. One row affected, all created, all good to go. So technically, we could use our terminal to write out all our like SQL commands and things like that, but the interface just really is not that great, and the environment isn't the best. So that's why we downloaded PopSQL, because it's just, we can see the output a little better. It's just better overall. So, uh-oh, unexpected identifier. Man. Oh no. So when did that pop up? Like after you typed in MySQL, like what, or the new database? And you were able to log in though? Like you were able to put in your username and your password and all of that? Man, okay. In all honesty, I'm not really sure why that happened. It's never happened over here. I've always just created a database and it was fine. And I'm so sorry, I'm not really sure how to fix that right now, but if you'd like, you can just still follow along. But okay, so now that we have our terminal mode all set up, we're gonna go back over to PopSQL. So your screen is gonna look just a little different than mine because you just like signed up, I guess. But oops, let me go ahead and bring it over so you can see it as well. Okay, alrighty, so this is where we create a new database. So I don't know, I don't want to go too far ahead, but for those of you who were able to download PopSQL, do you see a screen that's like similar to this where you can choose your database and choose your nickname and like all of that? If not, and I'm sorry, I guess you can just keep going. But we're gonna go ahead and use MySQL, obviously, because that's what we're working with. And like I said, I'm gonna nickname this SQL Workshop. Oops. Okay. The host name is just gonna be localhost, and we're gonna keep the port name the same as well. And we have to name it what we named it in our terminal. So we named it SQL Workshop, so that's what it's going to be, SQL Workshop. Username is root, and then the password is whatever you set your password up to be when you were creating, when you were downloading SQL. So we're gonna go ahead and click connect. I'd love to see it. Oh, okay. Okay. Anyways, I guess let's still in here. We'll start from scratch. So before we start with this, I just wanted to remind you all basically of the different character types that we were talking about earlier. So these are the different data types. So once again, we have varchar, which is essentially our string variable basically. But when it comes to varchar, we're able to set the length of the data that we'd like to store in it. So, you know, if we're doing names and things like that, I think 30 would be good enough, you know, so it's not arbitrary or anything like that. So we have varchar, and then we have int as well, just whole numbers. It doesn't hold decimal places, but we do have decimal. And so decimal is set up in a way like this. So the M represents the total number of digits within the decimal place, and then the N represents how many digits after the decimal. So if we were to say 3, 2, that means that there's 3 digits in total, but 2 of those digits come after the decimal place, because we have to be really specific when it comes to databases. And then lastly, this is just the date. Once again, that was a data type that you can use, and it's simply that, and it usually appears in this format. So clear your year, month, oops, month, day. So I just wanted to write out the actual data types just in case you forgot, and just so we can remember. Okay, so wonderful. We are in our database now, and we can actually go ahead and start creating our own tables and things like that. So that'll be the first thing that we do, which is create table. So like we saw with the commands listed out, super simple. All we do is type create table. And I'm gonna call this this table student, because the information that I'm gonna be pulling from is from a student table. And we do an opening and closing parentheses and a semicolon, and boom, that's how we start that's the first step of creating our table. But we'd like to populate this with some data. So in order to do that, we have to know what our columns are gonna be. Remember when we talked about attributes, etc. We have to know the column name, and we have to know the data type that we wanna use. So like I said, I'm going to be using a database of students. So I'm gonna pull that over so you guys can see exactly what I'm working with in case you'd like to follow along too. So this is exactly the same. Also, can you all see, do I need to zoom in or is it okay? Okay, alrighty. Okay, so this is the table that we saw in the PowerPoint, like I said, and this is basically what we're going to use to populate our table. So as we know, we have our Panther ID. So that goes first. And as we establish, our Panther ID is going to be an integer because it's just a whole number. And it's going to be our primary key. So remember when we said that each table has to have a primary key, no ifs, ands, or buts, it needs to have a unique identifier. That's where we put it first, okay? And then we can go ahead, I'm gonna call this next attribute student name. And then since it's a name, basically our data type for storing strings and things like that is varchar. And like I said, we create, it's the their own length for varchar. So honestly, I don't think anyone's first name exceeds 20 characters. So I think it's a good idea to just put it at 20. But you know, think about if you're making databases for really large data sets, you want to make sure that you're choosing values that won't take up too much space. So because this is just, you know, a simple little table, it doesn't matter. But imagine if you have millions of records, we need to be cognizant of how we store our data and how much space it takes up. And so lastly, we'll use our major, and I don't know, maybe we'll allocate 30 characters for a major. Some are a little longer than others when it comes to their name. Okay, so wonderful. We have this table here. So the best part about Pop SQL is the way that it can show the output like really quickly. All you have to do is highlight and it'll run it. So it gave me issues earlier, so let's hope that doesn't happen today. So let's go ahead and run it. So success. We see it says success and rows affected 0. So that's great, but we want to actually see, you know, what was done. So in order to do that, we write this command. So we write describe student colon or semicolon. And when we run this command, there we have it. It shows us basically all the data that's in our table so far. So we have our Panther ID, that's an integer, student name, that's varchar, major, that's also varchar. So here we go, all set and ready to go. And it's described our table. So that means we're ready to go ahead and input some data. Oh, actually, before we get there, I just want to show you all really quickly how you can drop and like modify a table. So if you remember, drop essentially means to delete a table. So all we have to do that is click drop table and student, semicolon, and we run that, and successful, 0 rows affected. So basically, if I were to type in describe again and run it, it would say failed because we dropped it, it's gone, you know, never to be seen again, alrighty? But we want to keep it, so that's okay. We'll just go back to create table, run it again, and it's back, okay? So there's that. And let's say after the fact, we're like, actually we want one more attribute. We can alter our table with the alter command. So we do alter table student, so that's the name of our table. And let's say we want to add an attribute for somebody's like grad year. So we would do add grad underscore year, run it. Oh, just kidding. Got a semicolon. Oh, just kidding. Wait, what did I do wrong? 1 second. Oh my gosh. Okay, very important. I missed something really important. So we want to identify what data type it's going to be. So it's going to be an integer. So we add that to the end, and that should solve it. It did. Wonderful. Alrighty, so we altered our table and we added an attribute of grad year. So once again, if we want to go and see what that looks like, we'll click describe. Student, run it, and there it is. It added our grad year. But since we're going off this table right here, just as easily as we got it, we can drop it in the same way. So same thing, alter table, student, drop column, and we'll say grad year, semicolon, run it, success, it dropped it. So great. Okay, so that's how we use the alter and the drop commands to modify some data. So that falls under the Dml commands. Alrighty, so like I said, let's get into actually inserting data into our table so we can actually store some things. So like I said, we're going to be basing it off of this table. I hope you, yeah, it says you all can see it all right, so that's good. So we start with insert into, okay? And we're going to use students. because that's the name of the table that we're using, and values, right? So pretty straightforward from here. We literally just go line by line and enter in the information that we'd like. So we'll start with Rory. We have his Panther ID, which is 1, 2, 3, 4, 5, 6, 7. And when we enter in a string, we use the single quotes. So Rory, comma, and then business, because that's his major. He's a business major. And we end it with our semicolon. I'll close this. Hopefully that helps. Okay, not really. Okay, alrighty, so what we can do here is, unfortunately, we do have to like add these values in line by line, but you can do it in different ways. So we'll click run, and it says success, 1 row effective. So now we successfully have 1 row in our table. So you can either delete this information and then just like go and do the next one, or you can just do it line by line. I like to do it line by line because I like to see like exactly what I'm working with, and so I don't miss any records. So we'll do the next one, which is Alex 7654321. Same as Alex, use information technology major. Okay. Next we have Alice. So her Panther ID is 5643217. Alice, and she's a computer science major. Okay. Single quote. Next student, we have Chris, so 7634512, 7634512, and then Chris, and he's a computer engineering major. And then we have Jordan, and their ID is 1237 654, and they're a computer science major. And then lastly, we have Molly, so 7651234, Molly, and communications major. So we can actually just select all these rows at one time and run it. Just kidding. 1, 2, 3, 4, 5, 6, 7, student primary. Okay, 1 second. Oh, I know why. Duh. I already added Rory, so don't do that. Just insert these right here and run these selected ones. Just kidding, I still did it wrong. So sorry. Select them properly. And so now that we've selected 5 fields, hopefully it'll let us run. Why isn't it highlighted? Hello? That's odd. Okay, alrighty, whatever that was. Insert and run them. Okay, it's giving me problems, so let's see. Let's start with this one up here, 7655321. Wonderful. Let's go with Alice. Run. Wonderful. Let's go with Chris. Okay, this is where it failed. 7634512. Student primary. That's computer engineering. I do? Oh my gosh, that's what I was thinking. I was looking. I'm blind. I'm so sorry. Can someone, where do I have them with the same ID? Alex and Chris? But they're not. This one's 765 and this one's 763. Yeah, that's really odd. Let's see, duplicate entry at 76345 and 2. Weird. Oh well. I'm just gonna go ahead and get rid of Chris now for the sake of time. Okay. Did I get rid of them? I didn't. 1 second. Well, alrighty, we'll go over to Jordan now. Okay. 1, 2, 3, 7, 6, 5, 4. Wow. I really apologize, guys. This is so odd. I don't know why this is all happening now. Let's see. It's from Jordan. Duh. Okay. I think you're exactly right. I think it ran already and I didn't realize it. Exactly. Yeah, I can make it show the whole table. So let's do that now. Let's move on to that and let's see if that'll fix it. So let's do select star or asterisk. So that means select all from the table. Select from student, and this should display our table. Success. I appreciate you guys. Thank you. So yeah, so I guess I didn't realize that it had created all of them already, but wonderful. We've got Rory, Jordan, Alex, Chris, Molly, and Alex, all of their majors and their Panther IDs all in our table. So great. Now we can actually start like using some like command lines and things like that to mess around with this data as well. I was about to just mention, this is in my notes, that you can't duplicate records, but you have seen that already as I've like duplicated it like 10 times. So I'm so sorry about that. But yeah, you absolutely cannot duplicate records. You'll get an error like that. Okay, so let's try the update command. So this is really interesting. I like to use this one because if we start here, let's say we want our information technology and our computer science, like it's too long, we want to abbreviate that, right? So we can write this command, update student, which is our table, and set major to, sorry, I'm put it on 2 different lines, set major to IT, where major equals information, right? So if we run this, success, and then we go ahead and click select so we can see how it affected our table, we can come over here and boom, IT, it's no longer that long, word, we were able to abbreviate it. So we can do it with the rest. I'm gonna go ahead and do it with the rest. Just for the purposes of like showing. So let's change computer science to CS, just so it's more concise. Okay, go ahead and run that and update. Ooh, just kidding. 1 second. Set major to set major to CS. Hello, computer science. All right, I'm just gonna grab that and try it again. Run that, success. And while we're at it, you can see him now, but he's still over here, Chris. He's a computer engineering major. So let's change his to CE and type in computer engineering, run. Wonderful. So when we go back to our select and we can take a look at how our rows look now. Now our CS and CE, or computer engineering and IT majors, are all nice and concise. We could like, I guess, abbreviate business and communication too, but this is just for purposes of like example, etc. So there we go. That's how we use the update command. I think that also falls underneath data modeling language. Okay, and so, right, so we're gonna go into deleting. So we figured out how to drop a table. So we're just gonna do a similar thing. We're gonna learn how to delete a specific student basically from our database. So let's say we just wanna go ahead and delete Rory's entry. So super simple, all we do is delete from student, where we can do a number of things. We can do where their name, I think it's student name, where their student name equals Rory, or we could do something like where their Panther ID equals 1, 2, 3, 4, 5, 6, 7, colon. It's all about how you want to manipulate your data and go about it. So if we click run and delete, let me go check our table. We no longer have Rory here, so it's gone. So, but you know, just as we added him, and just as we got rid of him, we can still add him back. So if we'd like, we can go ahead back to insert into, run it, and take a look. He's right back in there. Okay. Alrighty, so we use the select to select all the records, but we can also use select to select smaller, basically, queries in a way. So we do this with select. So let's say we want to select somebody's name and, oops, their student name and their major, and we just want to select it from our student table. We end that with a semicolon, and when we run it, now we have the names that come first and the majors, and it got rid of the Panther IDs. So we wanted to just see those two attributes. You're able to do that way as well. And let's say we wanted to order the students by name. We can do that too. So we do select student name and their major from student, and then we add this. So we add order by student underscore name, semicolon, we run it. And great, so now we have it alphabetically ordered, which is convenient for whatever reason you may need it for. Okay, so we're getting close to the 7:30 mark, and I didn't want to keep you all too long. Just wanted this workshop to be like an hour and a half or less. So I'm going to show you one more query. So obviously we're working with pretty like small sample sets, but I wanted to show you. I wanted to show you basically how we would work with two tables. So I'm going to go ahead and get rid of some stuff here because if you remember back in the presentation, we were talking about joins. This time I'm going to use unions. That wasn't in the presentation, but I thought it'd be interesting to show. This is how we join information from two tables. So in order to do that, we have to create our second table first, okay? So let me clear this all out. And go ahead and create our second table. So I'll show you what I'm referencing to create the second table as well. There's my finder. There it is. Okay, so once again, if you remember back to the PowerPoint, we pulled up a table that had the student's GPA and their credit hours, etc. So we're gonna go ahead and enter this info and as our second table, okay? So for the sake of time, I'm just looking at the clock. I have it copied, so let's see if I can copy and paste it and if it will freak out if I do that. So let's start with creating the table first though, before we can copy and paste anything. So we'll do create table. And we're gonna name this one, I'm just gonna name it student info because it's a little more information about our students. We have our GPA, we have their credit hours, etc. And we do our opening, closing parentheses, and a semicolon, right? And so going back to the PowerPoint when we were talking about primary keys and foreign keys, etc., this is when that comes into play. So we know with our student table, the primary key was the Panther ID, but with this table, we're gonna have to create a different primary key. Even though they share that primary key, which is the Panther ID, that's gonna now become the foreign key. So I'll show you in a moment. So with this table over here, we see entry num. So all that is basically, you know, which number in order the students were entered in. So let's start with that. So since that's going to be our primary key, this is the syntax for that. So entry num, it's an integer and our primary key, just like how we did with the first table. And so the next, we're gonna skip Panther ID for right now. The next attribute we're gonna use is GPA. So GPA decimal, going back to what we were talking about with these data types, we'll type it in like this. So 2, 1, because that's how our GPA show up. There's 2 digits, but there's only 1 value past the decimal point. Okay, so we'll do a comma there. And then their credits, which is simply an integer, comma. And then lastly, the foreign key. This is also where it gave me problems, so let's hope that doesn't happen today either. So the foreign key is the Panther ID. That's what they have in common. So we'll do foreign key, parentheses, Panther underscore ID. And we have, since this is a foreign key, it's like, okay, well, it's a primary key in some other table, so tell us where the primary key is in the other table. So this is what we do. We say references the student table, and it references the Panther ID in the student table. And that's how we create a second table with a foreign key, etc. So if you were working with other keys, it'd be a similar syntax. It just depends on which one you're using, but for simplicity purposes, we're just gonna use the foreign key. All right, so it's the same process. We're gonna go ahead and create that table. Okay, failed, great. Panther ID doesn't exist in a table. Alrighty. 1 second. Let's see if I copy it over. If that'll help it. Don't you need to create the Panther ID before using it? Yep, you're right. I missed that. Thank you. Thank you. So it's Panther ID underscore ID integer, comma. Thank you so much for catching that. Run. Success. Awesome. So in the same way, let's go ahead and see what that table looks like right now. So describe student info, colon. Great, so there we are. We have our entry num, our GPA, credits, Panther ID, etc. So like I said, for the sake of time, I'm gonna go ahead and just copy over the information so then I can show you all how I'm gonna do this last query here. We're almost done. Okay, so we'll go to notes and let me copy this over. So these are the exact values that you see in the table right now. They're just pre-typed. Okay, there we go. All right, so as you can see, we have our entry numbers, which is basically our different students, their GPAs, their credit hours, and their Panther IDs. It's a little different than how it's listed in the table, but obviously, as you know, you have to go in the order that we see here in the create tables. So entry num, GPA, credits, and Panther ID. Okay, so let's see if it'll give me another error if I try to run this all at the same time. Hope not. Wonderful. Okay, worked just fine. And now let's take a look at what we have. So select star student info semicolon. And we'll go ahead and run that. Just kidding. Wow, you guys. I'm already forgetting everything. Okay, there we go. There's our table all set to go. We have the entry numbers, their GPA, their credits, and their Panther ID. Okay, so I did all this to say, thank you. So I did all this to say how to use a query to join these two tables. So I put in their GPAs and their credit hours because let's do a query that's gonna bring back those who can be inducted into UPE. So as you know, to be a part of UPE, you can be any major, you can have any GPA, amount of credits, it's okay. You can come to any event, etc. But to actually be inducted into the organization, you have to be either an IT, a CS major, computer engineering major. I think I might be missing a major, but anyways, it has to fall under tech. You have to have at least a 3.0 GPA and at least 45 credits. So we want to extract all of that information from this table. So how are we going to do that? We create a query. So a query is essentially a block of SQL text. So let's go ahead and do that. So we start with select student name because we want it to return the names of the students who can be inducted. And so for that, we know that student name resides in this table. We don't have any names in the second table. So we'll say from the student table, right? So the next condition we need to meet is if they have an ITCS or computer engineering major. So when we do that, we'll do where their major equals IT. Oops. Use our operators, or if their major equals CS, or if their major equals computer engineering, okay? So there's that. So that's all information that we can get from the first table. When we want to get information from the second table, that's when we use the word union, because now we're going to join the two, right? So in the second table, we have their GPA. So like we said, it needs to be at least a 3.0. So select GPA less than or equal to 3.0. And they have to have at least 45 credits. So if their credits are, not less than, greater than or equal to 45, that's how we know they're going to be able to be inducted. So that information is coming from student info, that table. So let's go ahead and let me clear this out. Let's go ahead and run this and see what it returns. So successful. We have Alex, we have Chris, and we have Alice, and we have Jordan, which are the ones who can be inducted into the Honor Society, UPE's National Honor Society, basically. So we know Jordan, he's a computer science major. And if we see here, he's got the right amount of credits, he's got the right GPA. Same with Chris, Alice, and Jordan. So basically, that's kind of how you use a query to pull out these super duper specific ranges of information. So like I've been saying, like if you have, you know, millions of records to keep track of, this is going to come in handy. So this is obviously an intro to database workshop, so we're not going to go too much further deep into it, but there's things like subqueries, not just like nested if statements and things like that, where you can get even more specific and extract even more data in that way. So that's kind of the examples that we were going to use within SQL today. And also, I just want to apologize again. I'm so sorry for those who are on Windows and couldn't actually get the database to work. I know you all wanted to do it along with us, but you know, I'm sorry. Hopefully hopefully you can go back and look at this recording and apply some of it. There's different softwares that you can use other than PopSQL and things like that. So hopefully you can get your database connected in that way. But okay, give me one moment. Let me pause my screen, and then we'll go ahead and wrap up. 1 second. Alrighty, so that essentially concludes our workshop today. So of course, visit our website or contact us at our email right here. So like I said, over Discord and things like that, we're gonna go over more workshops that are coming up in the semester. And then as always, go ahead and follow us on social media. We're pretty active on there as well. And that's where we post upcoming events too. So I just want to thank you all for coming. I hope you were able to gain something from this. And this is recorded, so if you ever want to go back and look at it, it'll be there for you. And yeah, thank you all.